Good afternoon. I'm meteorologist Nathan Scott. Welcome to Weather-Wise. In this episode, we are going to go in depth of talking about how a forecast comes together in the first place. I've got my forecast sheet here. I'm a meteorologist. Every forecast that you see here on THV 11 is done by all of us. We don't take information from the National Weather Service and just copy and paste it over. We make our own forecasts. And this is my forecast sheet. It looks like chicken scratch. It's got a lot of numbers on there, but there's a method behind this madness. And pretty much this is what I do every single week. Just write down all the forecast numbers and then look back to see how I verify and if things are coming along as expected compared to what the forecast was just a couple days ago. But before we dive into models and forecasting, we have to discuss universal time because that's what we use as meteorologists to look at what the forecast models are saying, and this is the time that they use. So what is universal time? Well, it's the primary standard for regulating all clocks worldwide. No daylight saving time is included when you look at universal time. So if that's not adjusted, that can make the model data come in later. So looking ahead to daylight saving time begins March 8th. I'm not looking forward to it because the information will come in later than what we're seeing out there right now. Who uses it? People in aviation, meteorologists, military, and also computer programmers. So when we take a look at universal time, it's all based on the prime meridian, which is 0 degrees longitude. And we are seeing subtract hours and add hours. That's because everything starts here at the prime meridian. So for example, if it hits midnight, prime meridian, you have to subtract the hours west of the prime meridian and add hours to the east of the prime meridian. That sounds confusing, so let's go over to Storm Track 11 because this shows a nice breakdown on each time zone that you can expect on how this all works out. So if it is midnight right here, the prime meridian, the highlighted area, then as you go off to the west, you notice the hours get subtracted. 4 hours, then you get into Eastern Standard Time, you subtract 5 hours from what's happening at the prime meridian. So if we're looking at midnight at the prime meridian, then it would be 7 o'clock for Eastern Standard Time. And then for Central Standard Time, that would be 6 o'clock for us. And of course, when daylight saving time happens, then it would be 7 o'clock. So looking at the next graphic on Max, models come in every 6 hours. The long-term models, your GFS, your European, they come in every 6 hours. So it's known as 0Z, 6Z, 12Z, and 18Z. So with the Central Standard Time, that means the models come in at 6 p.m., midnight, 6 a.m., and noon. There are two important times of when the model information comes in. Your 12Z is going to be your most accurate and reliable. That's because real-time data goes into the computer information, into the calculations to figure out what the future is going to be. Of course, a weather model is just a whole bunch of calculations of physics and thermodynamics, all computed with these powerful supercomputers to come up with the model forecast, which shows everything that's supposed to be happening in the future, where highs and lows are and where precipitation will be developing. So our 12Z is the most accurate and reliable because it takes into account surface observations, but also upper air observations that are launched twice a day, which is 12Z and 0Z. Your 0Z is a little less accurate for some reason. It's not as accurate as the 12Z, but we still take it into account. Now your 18Z, that's good for short-term events. I don't really look at data 18Z when it's 5-7 days out. And certainly 6Z data is awful. It's the least accurate, it's hardly used. So if you see somebody on social media that has a forecast map, snowfall map or whatever, and says this is 6Z data, you should just ignore it entirely because most likely they're just looking for clicks and attention. No meteorologist uses 6Z data unless it's a very short-term forecast, such as maybe a line of severe weather is rolling through the region. But 6Z data long-term, more than 3-4 days out, it's really not worth it. So we have the times that the models are initialized: 0Z, 6Z, 12Z, 18Z. So when can I see the data? You can't see it right away because it takes so long for all these calculations to go into this computer and the computer to figure out exactly how everything's going to work and solve these calculations to develop these weather models. So here's the breakdown of when you can see the short-term data, which goes out to about 84 hours. Now the HRRR, which is the high resolution rapid refresh model, it's every hour, but your best is going to be 12Z, 18Z, and 0Z. You see that change. We use this especially when there's a line of storms advancing in here from Oklahoma. We look at the HRRR every hour as it gets closer and closer, and it will change. It will change where the position of the storms are located. It will change the storm mode sometimes, but it's really the 12Z, 18Z, and 0Z, because the 12Z and 0Z use real data that goes into it. The 18Z and other information estimates that data, which can lead to a wrong solution. Your NAM variations, they're done by 12, or they're initialized at 12Z, but they're not done until 10:30 standard time, Central Standard Time. So yeah, it takes 2-3 hours for all this computation to take place. Now a graph is every 2 hours, and that's our in-house model that happens here at THV11. Your long-term models, which go out to 384 hours or 15 days, initialized at 6 o'clock in the morning, standard time, but it's not completed until 11:30. And then your GFS ensemble forecast, it takes even longer than that. Your GFS AI, which we do use AI now, that's the new thing, is not done until 11 o'clock. Then your European model, it's not completed until 1 o'clock. So we're always getting new data coming in throughout the day, and we're always looking at more and more information. Your ensembles, which are a solution of the same model, but one little change is made that you come up with different solutions within the same model. That's known as an ensemble. They're not done by the GFS until 1 o'clock, and it's not done usually by the European until 3 o'clock in the afternoon. And that's standard time. So again, once we get into daylight saving time, you have to push everything back an hour. So that is what universal time is. And we look at that because when we look at weather models, you see it right at the top. It's going to say Z time or Zulu time or UTC time. Before I get into the models, as a meteorologist, I want to see what's happening right now. Because if the information right now does not match with what the models initialized with in the first place, then it's what we always say, garbage in is garbage out. So if garbage goes into the model, then what the model produces in the end is not going to be accurate most likely, and it's not going to be reliable. We can go over to Storm Track 11 now, Perry. This is a satellite view, and this is a gorgeous view. Now this was recorded February 23rd, and you see what is happening here in Arkansas. We've got clear skies. So this is satellite taking pictures from way up above the earth and develops into a loop. So we have some high clouds moving into the northern plains, but overall it's high pressure really controlled across the Mid-South. What stands out is this massive storm that they got walloped by a lot of snow. New Jersey, Connecticut, Rhode Island, Massachusetts. It almost looks like a hurricane. I mean, there's actually a clear area developing within the system because so much sinking air is going into it. And then what is cool about this is you have the wind coming off, that cold wind coming off from North Carolina and South Carolina, moving over the warmer waters of the Gulf Stream, and that produces these cloud streets. which is really cool to see and just kind of geeking out. But the shield of clouds right over New England. I'm going to go over to radar now. And this also shows the snowfall reports. So this was a massive blizzard. It has produced over 30 inches of snow in parts of Rhode Island. You see there 29 and a half, 24, there's 31 being reported by the public. And this purple band, that's still really heavy snow. That's probably about 1 to 3 inch per hour snowfall amounts happening as you get pretty close to Cape Cod. So someone's probably going to end up with over 40 inches of snow once all is said and done, and then these bands start to wind down the farther west that you go. But you see all these snowfall totals. I mean, it is very impressive. Almost 2 feet in New York City, over 20 inches. And then even into New Jersey, Philadelphia, everybody got clobbered by this snow across a large part of the mid-Atlantic and also the Northeast. So looking at the real-time data, I look at surface observations just to see how everything's playing out, because of course that's important when it comes to, okay, there's a front moving south. So how are the temperatures located in that part of the country compared to what the model was saying? Is the model too fast? Is it too slow according to the timing of the front? Because that plays a huge factor in the forecast. And also maybe looking at radar, are the storms moving faster than expected coming out of Oklahoma? Just to give you some examples. But let's just say it's a quiet day. So this is the first thing I look at. And this is a lot of numbers on here, and I realize that. But all these numbers tell different information. So first thing, KLIT, that is Little Rock. This is the NAM model. This is the GFS model. And then you pretty much have a condensing of the model here within the GFS, and that goes all the way out to the next 7 days. So really quickly, I'm going to break this down. There's your time, 18Z, 21Z, 0Z, 3Z, yada, 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 goes on and on. So this is looking at the next 2 days. The NAM saying for tonight, for the morning of the 24th, we're going to drop down to 23 at Little Rock. The high is 63, the low is 44, the high is 60, the low is 55. This is the temperature going throughout the entire night. Your cloud cover, so clear, 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 clear with the CL. FW is few. BK is broken, so more scattered clouds, and then OV is overcast. So according to this, looks like clouds will be on the increase. This is your wind direction, which uses 0 to 360 degrees. So you're looking at this, and due south is going to be 180, due east is going to be 90, due west is going to be 270. Wind speeds, probability of precipitation, 12 hours, or excuse me, 6 hours, 12 hours, and then your QPF estimates, which would be like an inch, 2 inches, probability of thunderstorms, and then winter weather. Your GFS says tonight's going to be 24, tomorrow 62, 49, 64, 51. So you compare those changes, looks like the low for tomorrow night is a little bit different, 49 versus 44. It looks like because maybe the GFS says the winds are going to be higher and maybe some more clouds. And then going over the next 7 days, here's that same breakdown. So 24, 62, 49, 64, 51, 72. So it's saying we're going to get into the 70s on Thursday, and then we get into the 60s on Friday, back into the low 70s on Saturday, turning cooler on Sunday, 69 on Monday. So that's just one information that I'm looking at when it comes to breaking up the forecast guide. And I write down those numbers, and then I look at the actual forecast model. So this is the GFS, and there's lots of pretty lines here, and we're going to look at different sections of the atmosphere. So here's a quick breakdown on what we're seeing here. First of all, this is the 12Z. So this was initialized right there, initialized at 6 o'clock this morning. This is the newest information, And then 18Z, as we advance this, you see what's happening, 0Z, so this is 6 o'clock this evening. All these lines tell us something. So first of all, we had the H, that's area of high pressure at the surface. We're looking just at the surface now. Big low, that blizzard right off the coast of New England. These black lines, they're isobars, lines of constant pressure. And where these lines are really close together, that's where you have a tight pressure gradient, which leads to strong winds. So we're having really high winds with that blizzard, and the snow's blowing all over the place. It's coming in 40 to 50 miles per hour, and that snow's causing a lot of drifts. But you see those pressure lines are really tight here, and then they start to break up the farther west that you are. So it's breezy from the Tennessee Valley, Ohio Valley, but that wind really picks up once you get into New England, and then also picks up out here into Kansas, Oklahoma, Texas, and up through the northern plains. But right now it's pretty quiet across a large parts of the Mid-South. So advance this tomorrow. Look what happens. This is Tuesday, February 24th, 18Z. That means it's 1 o'clock time frame, and the lines are coming in this direction. So airflow around a high pressure is clockwise, so it's going this way. Airflow around a low pressure is counterclockwise, it's going this way. So we're getting a southwest wind, and it's a pretty strong wind as those lines are close together over Arkansas. It's going to be a windy day on our Tuesday. That's definitely in the forecast, and that also heightens the fire weather danger because it's going to be that dry southwest wind, and also a southwest wind is a warm wind here. That's why temperatures will climb up very quickly from the 20s into the 60s going into Tuesday afternoon. Now here, what we also look for would be kinks in these lines. And these little kinks, just looking at this as an experienced meteorologist, I'm seeing a front, a cold front, right about here through Illinois, Missouri, because that line of constant pressure, that little kink right there is an indication that there's a boundary in that location. And as we go through here into Thursday, 12Z, we do have a little bit of a front trying to move through. It's showing green, that would be rain. Blue would be snow, pink would be a wintry mix. So the GFS is not saying too much in the form of rain is going to impact Arkansas on Thursday. It's a small chance. And then it looks like another front's going to try to move in here going into the weekend. There's the high pressure over Canada. That's going to pump in some colder air over the Ohio Valley. So that's why they're expecting winter weather. But that's only one part of this model that we're looking at. That's just the surface data. But I'm not just interested in the surface data. I want to know what's happening in the mid layers of the atmosphere. So this is the 500 millibar chart, and this is important because this tells us where there's rising air according to this wavy feature of these lines. So here's what we got going on right now. 12Z, Monday. This is what it was showing with that huge low pressure, because there's a relationship between what's known as a trough, where you see this dip right here. These lines are going down and then up, and you can almost think of a wave. So this is kind of like the crest of the wave, and this is the trough of the wave. So this is a ridge of high pressure out here, which would be most likely quiet weather, area of sinking air, especially if it's a very strong ridge. And then this area, you're going to have rising air. You divide this where this kink is and where the base of the trough is, you make a line, and everything pretty much to the right of that line is going to have a better chance of lifting the atmosphere and producing precipitation. And this is important when it comes to severe weather, especially because the orientation of where this axis, which is known as a trough axis, where it's facing, if it's southwest to northeast, that's a positive tilted trough. If it's facing northwest to southeast, then that's a negative facing trough axis. So southwest to northeast, positive, northwest to southeast, that's negative. And when you have a negative trough axis makes its way through, then you would have a better chance of more PVA, positive vorticity advection, which is basically more twist in the atmosphere to allow lifting mechanisms to happen and allow for a better chance of storms to develop, or in this case, winter weather. So we have a closed low here also. You see those ISO heights are pretty much closed off. So we've got a circle here, a circle here. That indicates it's a very powerful system. And we are looking at not pressure lines here. These are not constant lines of pressure. These are constant lines of height. And as we go through, you see how this changes. That wave moves out. Here comes another wave over the Great Lakes. And then there's a little disturbance right here. This is known as a little vortmax or a little short wave going through Missouri. This is 6Z Thursday, so that would be 12 o'clock at night for us, Central Time. The ridge out here into the Baja of California continues to develop. And then getting into next week, looks like a ridge is trying to develop, but there's a low pressure in that upper parts of the atmosphere happening over the Four Corners area. And where that goes, right now it's kind of up in the air exactly. But this is just one model. So we're just looking at one model. We take that into account. Now let's compare it to a different model. So now we're going to get a little more detail here when we look at different models. I love this website because we can compare and contrast on what the European is saying versus what the GFS is saying. So let me get my bearing here, and we'll just advance this just as a little example. So let's go to Sunday. So this Sunday, March 1st, this is the GFS. This is the surface chart. So we're looking at high pressure over Minnesota, Wisconsin, and then we have rain developing over Oklahoma and Arkansas. Look at the European. It's totally different. So European says it's not going to rain on Sunday, but the GFS says it is going to rain. So as a meteorologist, I have to figure out, okay, what's going to happen with that situation. Is that a trend? Is it right? Is it wrong? Looks like the European is holding it back a little more, and the GFS is a little faster with this system. But also the European shows the potential of snow into Missouri as we go into Monday morning. And the GFS has the snow well to the north. So as a meteorologist, I have to look at other information, because it's not just these two models that we look at. We look at the Canadian, we look at ensembles, to figure out, okay, now we're getting long-term information. Let's see what the trend is saying and then go with the trend. That, in turn, is going to affect the temperature forecast as well. Now, let's just take a look at the difference between the two models here in terms of what's going to happen later next week. This is Wednesday. All right, so Wednesday here, and you see this is the same time frame. This is 12Z Wednesday, March 4th, and look at the difference back and forth. It's almost like what an optometrist would say, 1 or 2, 1 or 2. You see the difference? 1, 2. That big circle area in California is more to the east versus the GFS when you compare it to the European. And also the ridge is different. So, of course, this is going to be different as we go into the next several days. It's going to figure it out because this system is most likely well out into the Pacific, and we're trying to figure out how things are going to move. We don't know right now. There's no way we can exactly say that's exactly going to be how it's going to look 7 days from now. Or actually, it's more than 7 days. It's 9 days from now. Another thing I look at, this is just the 850 temperatures. And we'll just advance this because this is going to be different. 18Z, March 1st, so this is Sunday afternoon. And let's see how this changes. So it's in pretty good agreement for Sunday. Let's go advance this here to Tuesday. And you see there are some changes there with that. I look at the dew points. So it's the dew points on Sunday. Really cold air into North Arkansas, and then according to the GFS and the European. So European has a lot more dry air in Missouri and also into Arkansas versus the GFS. This is the blend of models. So this takes into account the GFS, other model information, and blends it. This is fairly new. This has been out for a few years. But this is the breakdown of what the temperature scheme would look like here in Little Rock using that blend of models. Do we take this 100% with confidence? No. Because if one model is wrong and that model has more weight into the solution, then the forecast is not going to be exactly correct. So this is the blend of models. Overall, it says 60s. There's a 70 showing up on Saturday, but it's saying only 61 on Tuesday, 68 on Wednesday. I've got low 70s on Wednesday. It depends on cloud cover, and then 60s going into next week. And this is the European ensemble forecast. So the European model, different solutions within that same model. You get this as a consensus. It has a little more in the form of 70s, and you see all the box and whisker plots. So that is every single temperature that's trying to come up with. Of course, the consensus is going to be much closer in the short term, and then it really starts to divide and goes in all different directions as you get farther out in time. So that is how I come up with a forecast. I know it was a very quick lesson because there's a lot that goes into it, but hopefully you get a little more perspective and a little more respect for meteorologists, because this was quite the situation. When we're looking at severe weather, when we're looking at winter weather, it takes a lot of time and looking at a lot of data, and that's what I mean. When we're looking at data, and more data, that's what we do when we get here, and you may not see us on air just yet. Behind the scenes, that is our job. Before we wrap up weather-wise, there's something cool happening in the nighttime sky that you cannot miss. It's a total lunar eclipse, and it happens on March 3rd. I'll have more coming up. March 3rd, set your alarm to get up early in the morning because the moon will be going through a lunar eclipse. It's a total lunar eclipse of the moon, and we get to see it here in Arkansas. Now, you have to set your alarm like right around 4:30. Totality of this happens close to 5 o'clock in the morning. That's March 3rd. That's Tuesday morning that you want to go ahead and set your alarm. And this is going to be the last eclipse of the moon that we will be able to see here in North America until 2029. We have had lunar eclipses before, but this one I think is going to be a little more special because it happens when the moon is just about to go below the horizon, and that means we're going to have a better ability to see more of the reddish color, that rust color of the moon. Just like when you have a sunset, it gets close to the horizon, it has to go through more atmosphere that scatters out the light, the sun turns orange. Well, when you have a lunar eclipse, of course, this is just because the sun, the earth, and the moon are lined up in the fashion that the moon is going through the darkest parts of the earth's shadow, but there's still some sunlight that bounces off the earth's atmosphere, so the moon doesn't entirely disappear, but it produces that rust or reddish color. Hopefully, skies will be clear. The totality lasts for about 58 minutes, so it happens around 5 o'clock and it will be done by 6 o'clock, the totality part of it is, and then it will start to set below the horizon, and of course, sunrise will be happening pretty close to 6:30. So once again, check it out. If you get a picture, send it in our direction, 501-376-1111. Hopefully, skies will stay clear. We'll keep you updated on THV 11 with the latest forecast. That's it for this episode of Weatherwise. Thanks for tuning in. Next week, we got something special. We're going to be teaming up with the National Weather Service to, I'm not going to give it away, but it's something that you definitely want to tune in, especially if you love giving information on what's happening in your neighborhood when there is a storm or winter weather. So stay tuned for that. That's going to be happening next week. Have a great day, and I'll see you soon.